Hey everyone! Today we're diving into something that's absolutely critical when you're working with JAKA Cobots, and that's safety. We're going to walk through the safety settings, the I/O, the zones, but most importantly, we're going to talk about how a proper risk assessment ties it all together to make sure your application is actually safe before you hit go.
So here's the thing. A JAKA Cobot comes packed with safety functions right out of the box. But, and this is a big but, a safe robot is only the first step. True safety, a safe application, depends on the whole picture.
You have to consider everything. The tool on the end of the arm, the weight of the payload it's carrying, the layout of the workspace, and of course, how people are going to interact with it. Getting this right is the responsibility of the integrator, and it all starts with a risk assessment.
All right, so let's look at the tools JAKA gives you to build that safe application. We'll start with the most fundamental functions you have, the different ways to stop the robot.
First up is the emergency stop, or e-stop. This is your big red panic button. When you hit it, the goal is to stop all robot motion as quickly as possible, kill the power to the drives, and end the program.
And you can trigger it a few ways. There's the obvious one on the control stick, but you can and should wire in external e-stops, like pull cords or other buttons around the cell, using the dedicated safety inputs.
Now here's a key detail. The e-stop is a Category 1 stop, which means it's a controlled deceleration that has to happen within 250 milliseconds. But what if, for some reason, that fails? Well, there's a backup. The system automatically escalates to a Category 0 stop, which just cuts all power immediately. It's a critical failsafe.
Okay, next we have the safeguard stop, which you might also hear called a protective stop. Think of this one less like a panic button and more like a pause button. This is what gets triggered when someone breaks a light curtain or opens a safety door. The robot comes to a controlled stop, but the power stays on and the program is just paused, ready to resume.
So let's put them side by side. The e-stop is faster, it removes drive power, and it usually terminates the program. The safeguard stop is a bit slower, keeps the power on, and just pauses things. Knowing which one is appropriate for which situation is a huge part of designing your safety system.
All right, stopping is great, but it's reactive. What about preventing a dangerous situation in the first place? That's where monitoring and safety zones come into play. This is all about setting rules for the robot's behavior to keep people safe when they're working nearby.
A key feature here is reduced mode. You can set it up so that when a person enters a specific area, the robot doesn't stop completely. Instead, it just slows down to a safer, predefined speed. It's the core of many collaborative applications. And you create these areas using safety zones. You've got two main types. A safety plane is basically an invisible wall in space that you tell the robot it cannot cross. A safety cube is a full 3D box that you can define for the robot to either stay inside of or stay out of.
And the best part is, you get to decide what happens when the robot's tool or body reaches one of these boundaries. Does it trigger a full stop, a safeguard stop, or does it just enter that slower, reduced mode? The right answer depends entirely on your specific application and your risk assessment. Now, all of these features are only as reliable as the signals they get, right? A safety zone or an e-stop is useless if the system can't trust the signal coming in. And that's why we need to talk about redundant I/O.
First off, the robot is always communicating its own status back out to the rest of the cell. It's sending signals that say, hey, I'm in an e-stop state, or I'm currently moving, or reduced mode is active. This lets you coordinate with things like light towers or a main safety PLC.
But for the inputs, the signals coming from your e-stops and light curtains, it's even more critical. That's why they use what's called dual-channel redundancy. It's a simple idea. Instead of one wire carrying the signal, you use two.
Here's how it works. The system is always watching both signals. They should always be identical. If for any reason they don't match for more than a second, maybe a wire got cut or a relay failed, the system knows something is wrong. It immediately triggers a safety fault and puts the robot into a safe state. It's a fundamental way to make sure your safety circuit is robust.
So we've covered a lot of tools: e-stops, safeguard stops, zones, redundant I/O. But these are just ingredients. The recipe that puts them all together correctly is the risk assessment. And this is the most important part.
I mean, it says it right there in the JAKA user manual. A risk assessment isn't optional. It's not a nice to have. It is an essential, critical responsibility. As the integrator, the buck stops with you to ensure the final application is safe.
And the process itself is pretty logical. First, you identify every possible hazard you can think of. Then, you use the safety functions we've talked about to reduce those risks to an acceptable level.
And finally, and this is key, you have to validate it. You test every single function on site to prove that it works as designed.
The great news is you're not starting from scratch. There are well-established international standards to guide you. ISO 12100 gives you the overall framework for risk assessment. 10218 gets specific about robot safety, and TS 15066 is your go-to for collaborative systems. And 138049 helps you calculate the performance level of your safety functions.
So I'll just leave you with this one question to think about. Have you really validated everything before letting the robot run in production? Did you press every e-stop? Did you walk through every light curtain? Did you test every safety zone from every angle? Because if you make any change at all, no matter how small it seems, you need to go back and validate it again. It's the only way to be sure that your application is truly safe. Thanks for watching.